Hi, this is Yuan, and this poster is about Fisher market equilibrium. I hope it will be interesting to other researchers at Columbia working on topics related to algorithmic game theory and convex optimization. I hope it will also be interesting to practitioners in the fields such as ad auction, resource allocation, and recommender systems. So the classical Fisher market setup is as follows. There are a bunch of items and buyers, and our goal is to compute a market equilibrium such that the buyers are optimal subjectively, subject to their own utility functions and budget constraints, and the market is cleared, meaning that every item is sold. And this pair of allocation and prices is known as a market equilibrium. Usually we consider these three utility functions motivated by different applications, namely linear, quasi-linear, and deontive utilities. And a market equilibrium has desirable properties such as Pareto optimality, envy-freeness, and proportionality. For these different utility functions, and actually many more, there are different types of convex programs that capture market equilibrium, meaning that we can solve these convex programs to get an optimal solution and a bunch of dual variables that turn out to be a pair of equilibrium allocations and prices. So this framework has found a lot of recent applications in ad auction, resource allocation, and recommender systems. So in a recent work, we, Christian and I, looked at first-order methods for computing market equilibria through solving these different convex programs, some of which are derived by us. And we show that many first-order methods work very well with strong theoretical convergence guarantees, as well as strong numerical performance. Then, motivated by real scenarios in which there are many items, like a huge number of items, we consider an infinite dimensional extension of the classical theory. And we show that there exist infinite dimensional convex programs that capture Fisher market equilibrium under a continuum of items, meaning infinitely many items, where an item space is like a compact subset of a Euclidean space. And under further assumptions on the item space and valuation functions of the buyers, we can show that some of these convex programs can be solved efficiently and through like a finite dimensional reformulation into tractable convex programs. Finally, with Christian and Alex, we looked at an online variant of this Fisher market, meaning that items arrive sequentially and they must be allocated to buyers without recourse. And we propose this simple and distributed dynamics that ensure the items are allocated in a fair manner and every buyer gets allocations that averaged over time is asymptotically Pareto optimal, envy-free, and proportional. This is derived by applying a specific stochastic optimization method to solve a dual of one of these convex programs. Not only it has strong theoretical guarantees, it works extremely well on real data sets. Thank you.